Yeah, but it's the particular element that we're talking about, not the whole substance.
Okay.
And then the half is like when you have something that's not right, and you use half.
No, the half reactions is the splitting them up.
Oh,
Because there's one whole reaction, and we're splitting it into two parts, we're splitting it in half. You know, with the oxidation reduction separately. That's called the half reaction.
That was easy.
Yep.
Are they always going to be on the reactive side?
The oxidizing and reducing things? Yes.
Wait,
Yep.
I don't know what to do with this one.
Okay, so that's a toughie, isn't it? Okay. I don't know that you got any guidance to that. Let's see. That is what it is. Let's see. Wow. Didn't think of that. Okay, so here's an example that if I gave you this on a test, you probably wouldn't know what to do, all right? Because I'm not giving you enough information here. But let's just say this, first of all, is it clear to say is it clear to see that something's happening with this?
yeah.
Okay, so manganese is going from +4 to +2, it's being reduced, right? So something must be being oxidized. What's being oxidized is the question. Okay, well, these were 4 and -3, okay? And if we take O out of the mix, all right, that would not add up to -1. You guys follow that? So the only way that this could really add up to -1 is if one of these was -4 and one of these was +3, okay? Huh, that's really hard. Yeah. Okay, I'm just saying, I don't think that I could really pose a problem like that to you on a test because that would be kind of unfair. But we're looking for something to go up, all right? So what if we call this +2 and we call this -3 because carbon can be a variety of things. Nitrogen can be +3. So here is a case where I would say you want to be a little bit creative, okay? And again, in homework, okay? On the test, I would not throw something like that in. Or if I did, I would have to give you some guidance because that I think is a little beyond what we're expecting. Is that fair enough of an explanation? So once you get there, is it okay to go forward? Yeah. Okay, so let's go now. So who are our guys getting oxidized and reduced? Carson was doing oxidation and Adam was doing reduction. And once they do that, then we have Nick write the oxidation reaction and Michael Bevan write the reduction reaction. And I'm going to take over and go kind of quick. So hopefully what you see that I did, what I kind of did is I just used logic and said, okay, well, I don't know what either of them are. I know they got to add up to -1. So I kind of looked at CNO and saw what that was doing, and I realized that that couldn't make sense. So let's see where we go from there, and I just kind of played it out. Okay, now in terms of time, I'm going to go from CN negative to CNO negative. And I'm sorry I asked you guys to write this one. I'm kind of taking over because of time. MnO4 minus yielding MnO2. Atoms other than hydrogen and oxygen, C's and N's are good, C's and N's are good, MN's are good. Oxygen using water, so I'm going to have H2O plus Cn minus yields CnO minus. Here I've got 4 and 2, so I'm going to bring in 2 more on the product side. MnO2 plus 2 H2O. H's, I got 2 H's here, so I'm bringing 2 H plus on that side, H2O. And you can take a picture of this at the end if you want. Does that make things easier? Is that good for you guys?
Sure.
And then this, I got 4, so I'm going to bring 4 H pluses over here. And copy everything else. Okay, now since this is basic, I got to add to both sides of the equation, I got to add an equal number of OHs. So I'm going to add 2 OHs to both sides here. So 2 OH minus here, and 2 OH minus here, and that's going to be my 2 water, Mn. gonna add 4 OHs here, and I'm gonna add 4 OHs here. And so I'm gonna rewrite everything making this water and then worry about my charge. So 2OH minus plus H2O plus Cn minus yields CNO, you missed the minus sign, plus 2. Let's see, this side is 2 negatives, 3 negatives, this side is 1 negative, so I'm gonna bring in 2 more electrons on this side. Rewrite everything, this is 4H2O plus MnO4 minus yields MnO2 plus 2H2O plus 4OH minus. This side's 1 negative, this side's 4 negatives, so I'm going to bring in 3 electrons over here. I see comment number 6. Okay. So I'm going to multiply this by 6. So that's going to become 18 electrons plus 24 H2O. Oh, I'm sorry, 2. I want 6 to come out, right?
Right.
There you go. 6 electrons plus 8 H2O plus 2 MnO4 minus yields 2.
Is it Markley?
And yep.
I'm good.
Am I okay?
Yeah, I'm good, man.
OH minus. Okay, and then I'm going to take this one, multiply everything by 3. So it's going to be 6 OH minus plus 3 H2O plus 3 Cn minus. Listen up, guys. Plus 3 CNO plus 6 H2O plus 6 electrons. Make it. It's going to be tight. 6 electrons goes away. 6 electrons goes away. I've got 3 waters over here. That'll leave 1 water there. I've got 6 OHs here going away, leaving 2 OHs here. That looks like everything. Oh, H2O. Oh, and then these 6